So now we'll discuss the orthogonal property of Legendre polynomial. We also discussed the orthogonal property of Chebyshev polynomial. What is the orthogonal property? Is actually the product of that two polynomials is zero. So we can write as that is as a statement. So let, or I can say state and prove the property of Legendre polynomial. That is also I can ask you as an exam. But the statement I can write down as Pn of x be the sequence of Legendre polynomial then prove that integration from -1 to 1 Pm of x into Pn of x dx is 0 if m is not equal to n and 2n upon 2m plus 1 if m is equal to n. So this is known as the orthogonal property. Whenever orthogonal is there, it has to be product of two polynomials. Something relation of the product of two polynomials is there. Like when I say the orthogonal vectors, then it is x dot y bar is 0. Then we can say that this x bar and y bar are orthogonal vectors. So a similar manner, here orthogonal polynomials are there. So it is kind of integration from that range. Product of that two will be 0. If they are not, if they are different, if they are equal, then some constant quantity will be there. That is called the orthogonal property. In general, in any polynomial is there. So in particular here we have to discuss the same thing for Legendre polynomial. So to discuss this, let us consider this f of x be any function which has n continuous derivative on -1 to 1. So we'll consider this a continuously derivative between -1 and 1. Consider I is equal to -1 to 1 f of x Pn of x dx. Now using that Rodriguez formula, we get I will be, so we substitute the value of Pn. The Rodriguez formula that we have discussed, it is Pn is minus 1 upon 2 power n factorial nth derivative of x square minus 1 power n. So we'll write down that value here. And this 1 upon 2 power n into n factorial is independent of x. So that I can write down outside this integral. F of x into nth derivative of x square minus 1 raised to n dx. And using the integration by parts, two raised to n into n factorial. Using the integration by parts, what we can say? This fx, I will treat it as u, and this will be treated as v. So this is fx into n minus 1 upon x raised to n minus 1, x square minus 1 raised to n. So u as it is, integration of this quantity. So it is a derivative and then integration. So that's why it is one less derivative is there. Then limit minus 1 to 1. Minus integration. So what is the integration by parts? You know that it is u as it is derivative of v dx minus integration du by dx integration v dx, and whole integration is there. So this whole integration is here, this sign is here. Now du by dx, that is a derivative of u, that is f dash u or f dash of x. Then it is integration of v. V is this. This is nth derivative. If I take the integration, then it is one less derivative is there. So it is n minus 1 upon x raised to n minus 1, x square minus 1 raised to n dx. And this bracket is over. Now if I substitute 1 here in that, and for minus 1 also, what will be this quantity? So it is nth derivative or n minus 1th derivative of that will have x square minus 1 term there. So that's why if I substitute 1, then this quantity will become 0, and when I substitute minus 1, then also that quantity will become 0. So that's why this first quantity will become 0, only this quantity will be left. So let us write that is, so therefore I equal to minus 1 upon 2 power n into n factorial minus 1 raised to n, sorry, minus 1 to 1 f dash of x n minus 1 upon x raised to n minus 1 x square minus 1 raised to n dx. This is because this term n raised to n, sorry, n minus 1 the derivative of x square minus 1 power n becomes 0 for x is equal to 1 and x is equal to minus 1. I will use again integration by parts here. We get, again use this same thing. So your I will be minus 1 upon n factorial. Into the similar manner, what will happen? This is your u and this will be your v. So in the first, you will have u as it is, f dash of x. Then it is integration of this quantity, which is n minus 1, the derivative is already there. And if you integrate that, you will have n minus 2 derivative there. X square minus 1 power n. And limit is from minus 1 to 1. Then again minus 1 raised to n. The derivative of f dash, which will be double derivative of f. And then it is d power n minus 2 d n minus 2 derivative x square minus 1 power n and dx. Again, this quantity will become 0 by the same argument which I have given here. So the quantity, this will become minus minus plus. So the quantity left is I is equal to 1 upon 2 power n into n factorial minus 1 to 1 f double dash of x n minus 2th derivative of x square minus 1 raised to n dx. And if you continue in this manner, so after n steps like this, same manner, what will we get? I is equal to. So you can observe that there is a next time when you do, it will come minus sign. So it is alternating sign. So it will come minus 2 to 2 power n into n factorial integration from minus 1 to 1. So when you do the nth, this is the second step. So then when you do this, the second step, then it will be nth derivative x square minus 1 power n dx you will have. Because in that step, x square minus 1 power n dx is there. Now case number 1 that we need to discuss, that there will be possibilities that this m is equal to or is not equal to m. First of all, let us consider that. Now there will be two cases. If m is less than n, then let fx equal to pm of x in this equation. Into this, if I consider this is as equation 1, then if I consider that is as this is as 1, and if I replace this f of x is equal to pm of x in 1, then we have integration minus 1 to 1 pm of x pn of x dx. As for this, because this quantity is from the equation 1 we have written on this side, instead of f we have pm of x, that is the nth derivative will comes here. So this is minus 1 raised to n upon 2 power n into n factorial minus 1 raised to 1, sorry, 1 integration from minus 1 to 1 pm nth derivative x square minus 1 raised to n dx is there. Now what is nth derivative of pm? If m is smaller than n, then what is the degree of pm? It is m, and m is small, and it is a polynomial. So that's why this derivative will become 0. So we can write, since m is less than n and pm of x is a polynomial of degree m, so that pm n power x will become 0. So we can say that minus 1 to 1 pm of x into pn of x dx is 0 due to this argument, that is m less than n, due to this quantity is 0. So that's why this will be 0. So that orthogonal property is there. Now in the case if your n is smaller than m, then from 1 we replace n by m. If you replace n by m into the equation 1, so what was the equation 1? We just see that I equal to fm fx into Pn of x. So instead of that n, we write down m. So it will be minus 1 to 1 fx Pm of x dx is equal to minus 1 raised to n upon 2 power m factorial minus 1 raised to, sorry, integration from minus 1 to 1 mth derivative of fx x square minus 1 raised to m dx. Now let fx will be Pn of x. Then this will be integration from minus 1 to 1 Pn of x into Pm of x dx will be minus 1 raised to m upon 2 power m factorial minus 1 raised to, sorry, integration from minus 1 to 1 Pn mth derivative of that x square minus 1 raised to m dx is there. Now again by the same argument as we have did here in the previously, since n is less than m and Pn is a polynomial of degree n, then Pn x mth derivative of this will be 0. So finally in both the case we have this. If m is not equal to n, in any of the case we have this. Now case number 2, that is m equal to n. What will happen if m is equal to n? Then by equation 1 we'll consider f of x is equal to Pn of x there. So that will be minus 1 to 1 Pn of x Pm of x dx equal to minus 1 raised to n upon 2 raised to n into n factorial minus 1 to 1 Pn nth derivative of that x square minus 1 raised to n dx. But n is m, so both of the quantities are same. So that is gives you Pn and its nth derivative x square minus 1 raised to n dx. And we know that if the Pn of x is a polynomial, is of the form an x raised to n, an minus 2 x raised to n minus 2 up to so on. And if I take the nth derivative of this, then the constant term will remain. That you should know. And n plus 1th derivative will become 0. That's why in the previous cases we have did that. So when we have, this is the, we note that Pn is of this form, then the nth derivative of that Pn is the nth, that is a constant term. But what is the constant term into n factorial? Because first time you will do the derivative, it will be n, second time n into n minus 1. If you do the nth derivative, it will have n factorial. But what is this an, which we already calculated, that is 2n factorial upon n factorial square into 2 power n into this n factorial is there. So this 1 n factorial is cancelled out. So finally what we got as this Pn nth derivative of Pn will be 2n factorial upon n factorial into 2 power n. And so, if we substitute that value into that integration, we will have minus 1 raised to n upon 2 power n into n factorial integration from minus 1 to 1. This value is there because we have to substitute that value here. Tn and the derivative of that we substitute there. So that will gives you 2n factorial upon 2 power n into n factorial into x square minus 1 raised to n into dx. This is the quantity we got. So this is finally what we get. It is minus 1 raised to n into 2n factorial upon 2 power n whole power 2, so that is 2n and n factorial square minus 1 raised to 1 to 1 square minus 1 power n dx. Now the question is how to solve this, and the answer to this one is using the reduction formula probably will gives you. But this is the minus 1 to 1 is there, so I can convert from 0 to 1, and since this is an even function, so I can write down this is from 2 times 0 to 1. So this is minus 1 raised to n 2 times 2n factorial upon 2 power 2n n factorial square into 0 to 1 x square minus 1 dx. Due to the quantity that fx dx minus a to a will give you 2 times 0 to a fx dx if f is an even function. This is the quantity probably you know. So that's why this is the quantity we have. Now we need to integrate this quantity. So let us try to integrate that. So can any suggestion to integrate this quantity? Integration from 0 to 1 x square minus 1 raised to n dx. What will you do to integrate this? You will assume x is equal to sine theta. So this will imply dx is cos theta. If x is 0, sine theta is 0, so theta will be 0. If x is 1, sine theta is 1, will imply theta is pi by 2. So this integration I1 I can say is 0 to pi by 2 x square minus 1, x is sine theta, so it is cos square 1 minus x square is there, so it is minus cos square or d theta raised to n dx is cos theta. So this is minus 1 raised to n 0 to pi by 2 cos raised to 2n minus 1, sorry, 2n plus 1 theta d theta. This is the quantity we got. And this quantity or the value of this one is reduction formula. What is the reduction formula? Let me write down that here. That is 0 to pi by 2 cos raised to n theta d theta is n minus 1, n minus 2, n minus 3 up to 1 or 2. This is up to also 1 or 2 into k, where k is pi by 2 if k is even, 0 if k is odd. Okay. So due to this, now we can write down this is as minus 1 raised to n. This is 2n plus 1. So it is an odd number. Okay. So there is no k is come. It will come 1. Here 1. So it is 2n plus 1. 2n plus 1. 2n. 2n minus 1. 2n minus 2 up to 2, and here is up to 1 will be there. Now what will be this? That we need to adjust. So in the numerator, so what we get, let me write down here, that I1, or I can say in the previously what we have is this quantity into this integration, and this is I1 we have assumed. So let me write down first this one. So that is integration from minus 1 to 1 Pm of x, Pn of x dx will be minus 1 raised to n into 2n factorial into 2 upon 2 power 2n into n factorial square into integration that I1. I1 we have calculated in the previously, that is 2 times minus 1 raised to n, minus 1 raised to n into denominator 2n, 2n minus 1 up to 1, numerator is 2n, 2n minus 2 up to 2. So this is the quantity we have. First of all, this minus minus become plus, so it is plus 1. This 2n factorial is already there, and this 2 upon 2n plus 1 I am writing separately. Denominator is 2 power 2n into n factorial is there square. Now from this quantity you can take out 2 common, so there are n times 2 common, so you will have 2 power n into n minus 1 up to 1. In the denominator I will multiply and divide by 2n here. So 2n is multiplied, 2n minus 1 is already there. Then I multiply 2n minus 2 and divide 2n minus 2 up to so on. 2 is multiplied into 1. So here the last term is 2 is there. So this quantity is actually 2 factorial, and that 2 factorial is cancelled out with this. So finally we'll have 2 upon 2n plus 1. And this 2 raised to n, this is also exactly the same thing. This quantity is, we can write down 2 raised to n into n factorial as we have written here. It is exactly the same thing which we have here. So this quantity 2 raised to 2n is cancelled with this, and this n factorial square is cancelled with this n factorial and this n factorial. So only left quantity is 2 by 2n plus 1, and that is our objective, is to prove the orthogonal property of Legendre polynomial. That's it for this video or this lecture. If you have any question, you can ask.